My name is James Almanacid and I'm a researcher at the Geoenvironmental Cartography and Remote Sensing Group located at the Polytechnic University of Valencia. I normally work on issues related to cartography, remote sensing, and photogrammetry. During the next videos, I will be your guide in this module of three-dimensional characterization methods applied to beaches and dunes. This module consists of 6 videos. This first video is the only theoretical video. It is very short and serves as an introduction to the following videos, whose content is eminently practical. The following 5 videos serve as guided activities to solve 4 specific practical cases in which work with three-dimensional information. These video tutorials make use of freeware packages that will give the student autonomy in the future. These videos show the installation of the most unknown programs, its use and interpretation of the results. All this linked to the management of dunes and beaches. You will see briefly the features of two-dimensional information before we delve into the characteristics of three-dimensional information. In this image, we can see a cloud of points LiDAR considerably dense. But we can already observe that the aquatic areas or with high slope, they are likely to have lower point density. When we talk about two-dimensional information, or TWAD, we are mainly referring to images or raster. Traditionally, we will talk about aerial images whether they are taken from a plane, from a drone or satellite imagery acquired from a satellite, obviously. Two types information are usually extracted from the images, geometric or spectral. The clearest example of geometric information is obtaining of the coastline. The evolution of the coastline is a widespread indicator. It is a very accurate indicator when deduced from aerial images, or images taken from a drone that have a high geometric resolution, however. Its power has been extended since it has been possible to get coastlines from satellite images given Thaton, although they may have lower geometric resolution. They do allow to build long-time series of data and get the evolution of the coastline over time. Satellite images, on the other hand, offer spectral information that can be used to generate indices, obtain areas of water or land, or classify types of land or water cover, as well as analyzing time series. In addition, it is recently trying to obtain bathymetry based on the multispectral information of the images. The example image shows a fragment of coast in a reservoir over time. As the water level rises or falls in this reservoir, position of the coastline is modified. Three-dimensional information usually referred, on the one hand, to data of the type point clouds, and on the other hand to the digital models as digital terrain models, or digital surface models. A point cloud refers to a set of defined points in 3D space, that is to say, with coordinates size. One of the most recurrent methods to obtain these clouds points is the use of laser scanners or LiDAR. It is a laser sensor that is able to record millions of points per second. In case this sensor is incorporated in an airplane or a drone. We'll talk about aerial laser aerial scanner with the acronym ALS, in case the sensor is on a tripod above the ground. We'll talk about terrestrial laser scanner with the acronym TLS. Obviously, both a photogrammetric flight and a LiDAR flight can be very expensive, and therefore, it is a type of data to which recourse is not often made. However, a LiDAR flight can offer a lot of information and cover large areas. At the same time, a terrestrial laser scanner allows to obtain an immense amount of points and details, but with a small spatial coverage. The image shows a colored aerial flight with images in false infrared color. The photogrammetric flights from a plane are not overused for its high economic cost. In addition, the aerial images taken from plane usually present too much uniformity in the sand spaces, which prevents triangular points on the sand reliable enough, although it is not impossible. Acquiring aerial imagery from drones has certain advantages. Flights are obviously cheaper, which in turn allows data to be acquired more frequently. In addition, since the acquisition is usually taken at lower altitudes than from an airplane, it is possible to better distinguish the textures, better triangulate points, and get higher points density. In the image, you can see an aerial photograph of a beach space. It can be noticed the homogeneity of color in the sand, which could hinder distinguishing singular points in various images with which triangulate the position of these points and generate the three-dimensional point cloud. Finally, photogrammetry can also be used from images taken from the ground. This is called terrestrial photogrammetry or photogrammetry of a nearby object. Technique also used in heritage and archaeology, as in the case of the laser terrestrial scanner. The main limitation of this technique is the small space that you can cover. However, taking pictures is faster and it allows to cover more surface than using a laser terrestrial scanner. Terrestrial photogrammetry also has the advantage that the equipment is smaller and much cheaper than a laser scanner. Although later photogrammetric programs will be required to get the point clouds from the photographs taken in the field. The image shows a fragment of the beach whose points has been obtained from GoPro images and subsequently processed. There is a high density of points where you can see even the micro shapes and footprints on the sand. Another three-dimensional data, apart from the point clouds, are the digital models. In the beach spaces where sand predominates, it doesn't matter to talk about digital terrain models. Digital elevation models, digital surface models, because what distinguishes them is the type of elements they contain. Normally, a digital elevations model, which is often confused or equated to a digital terrain model, refers to a digital model representing bare soil without vegetation and without artificial elements, such as buildings or bridges. A digital surface model often also represents the altitude of trees and buildings. In the beaches and dunes zones, if there is no representative or important vegetation, all three types of digital models can be used without distinction. Digital models are images in which each pixel contains an altitude value. Since in a geo-referenced image the pixel size is known, each of these pixels represents a column with known altitude and therefore it is an indicator of volume of sand that contains that pixel, i.e. Digital elevation models are a tremendously useful resource to calculate and represent volumes. The image shows a digital elevation model, and in particular, the levels of gray are adjusted to be able to see the small variations of the sand in the beach area. In a practical case, it is possible to calculate the differences of sand volumes. In this case, two digital elevation models are available so as to calculate their difference and assess the volume loss between the two dates. This will be dealt with in a practical and detailed manner in the following videos. So far, the introductory video of this module, three-dimensional characterization of beach and dune spaces. Thank you for your attention.